All right, so for energy stored in capacitors, remember, one of the primary purposes of capacitors is to store energy so that you can save it and use it later. And that has a ton of applications in circuit solutions to different problems that we might have. Um, Let's see, I think we might have watched this magazine video. This was with Colin, who's talking about the history of capacitors and also how capacitors store energy. I'm not sure if we have. I'm going to go ahead and list the link here so you can watch it if you like. It's just a few minutes. Now, the energy that's stored in capacitors is given by this expression. That is that the energy stored in a capacitor is equal to 1/2 times the capacitance times the voltage squared, that the voltage across that capacitor. These are fairly simple. So for example, if I have this 10 microfarad capacitor with a 2-volt battery hooked up to it, what is its energy? So the energy is just 1/2 CV squared, or 1/2 times 10 microfarads times 2 squared, 5 times 4. That's going to be 20 microjoules. 20 microjoules. So in this way, you can determine how much energy is in our capacitor. And if we assume 100% efficiency, which, in some electrical devices is not a terrible assumption, then we'll get that much energy out, whether it be in the form of light energy or mechanical energy or heat energy. All right, that's really all we're going to get to with the energy. So it'll be fairly simple, just a simple setup. I want you to know that capacitors store energy and then also be able to do these simple calculations. I think there is a quick test question here. Yeah, so this one is very simple. Something that we'll see a little bit later is that the amount of energy on the capacitor, that it increases with time. And we'll see this in the next chapter. If we plot the energy, or we can also think of it as the charge versus time, when you hook up a capacitor, it actually increases with time. And at some point, that energy maxes out. And actually, let's see, I'm sorry, I drew this incorrectly. We'll see this in a later one. The function looks like this. And at some point, that energy maxes out. And we'll talk about that time a little bit later. It's called the time constant for a capacitor in the next chapter. And also we'll see that this is another great purpose for a capacitor, is that it discharges and charges at a very regular rate that is just dependent upon the circuit. And you can use that for building circuits or devices that repeat at a variable rate that is a definite rate. All right, so we'll stop there with chapter 2. It's a long chapter with lots of information in it. Do the quick test questions and submit your answers online. And also you can find the concept test questions there in the back of your book, and you can submit those online as well. Also, we'll be practicing those old tests because this test is just around the corner.